Hello, ladies and gentlemen, and welcome back. Welcome back, one and all. We're looking at question 2 on our 2019 Hypatia. A bump can be added to any line segment through the following process. Break the segment into 3 segments of equal length, remove the middle segment, add an equilateral triangle-shaped bump with each side length equal to the removed segment. Now I think this is the Koch snowflake, actually. Something like that. The Koch mountain range or something like that, or it might be pronounced Coke. I can't actually remember. But this is the start of a fractal. Cool. I don't think that'll have anything to do with it, but if you're interested in looking this up, it's I think a kind of fractal is what they're getting at here. Anyway, so they've got this process down here. It started with a segment of length 3, broke it into 3 segments of length 1, removed this one, sort of added the top half of an equilateral triangle, or the top of an equilateral triangle. Okay. The series of diagrams below shows a bump being added to a line segment of length 3. Actually, is that where we're going with this? Yeah. This is what the snowflake looks like. You basically do the process once, and then you do it to each line again, and then you do it to each line again. Very cool stuff. Anyway, so we got 2 light bulbs and 2 written portions here. A line segment has length 21. How long will the path be after the bump is added? Okay, this is not too bad. We can visualize it if we want. I mean, the question's basically added just to make sure we're understanding the process. So divide this 21 into 3 segments. Those will each be of length 7. So we lose a length of 7, but then we add 2 more in, and we can count 1, 2, 3, 4 7s. 28 will be the new length. That's it. That's all there is to it. Okay? Basically, anytime you start with length 3L, at the end you'll have length 4L. Okay? That's the general rule. But they added there just to make sure, did we understand the process we were just told? Okay, B, a path with exactly 1 bump has length 240. How long was the original line segment? So again, it's probably worth writing this rule down. If we start with a line of length 3L, we end with a path, because I wouldn't call it a line anymore, of length 4L. And you can even, if you wanted to prove it to them, use their own little pictures against them. Okay? But, so they're asking me to say, all right, at the end of this process, I've got 240. So that's 4L. That's the total length I've got now. Divide by 4 on both sides. The L we had is 60. 60 is not the answer, because remember, you start with 3L. So that'll be 180. So we must have started with a segment of length 180. If you want to double check, do the process normally. Take 180, divide it in 3s, and you can even draw out the little bump happening. Okay? Now, here's where we actually have to write things. C. Lynn starts with a line segment that has length 36 and adds a bump to it. She then adds bumps to each line segment of that path. The resulting figure is shown below on the right, so just keep bumping. Okay. What is the total path length of the resulting figure? Okay, so we do need to write things out. So I might say, as already noted, every time we bump a length, I might say the total length gets multiplied by, it's 4L when we're done. It starts with 3L, so it's 4/3. Right? Multiply by 4/3, and you can check that's 4/3 times 21 is what we've had. 4/3 times 180 is 240, and that sort of a thing. And this is actually true for all these lengths. Now, we might say something like, if we start with a length of 36, then we get, after a bump, four segments of length. So 36 over 3, 12. So now in total we have 48. Each one of them is 12. Each of these for 12 lengths gets a bump, increasing each segment's length by a factor of 4/3. And so that'll be, so 4/3 times 12. So 12 over 3 is 4. 4 times 4 is 16. So 4 times 16 is 64. So that's one way to write it out. I think the craftier way to write it out is if you start with a single line and you bump, you do the bump process to each segment k times, you'll end up with 4/3 to the k times your original length, the original length. So in this case, 4/3 squared times 36 gives us our answer. Okay? But, you don't have to be that fancy. Alternatively, you could. It doesn't really matter. I think it's actually just a matter of preference, really. Okay. So, D part. Anne starts with a line segment having length equal to some positive integer n and adds a bump to it, resulting in path 1. Then she adds a bump to each line in path 1, resulting in path 2. So now is sort of the time to say what I just said a moment ago. She continues this process to create path 3, then path 4, and finally path 5. If the length of path 5 is an integer, determine the smallest possible value of n. Okay? So again, you could use little pictures to justify this, but I'd probably say something like, since every segment after a bump has occurred is of the same length, we can see that after bumping k times, we get a path of length 4/3 to the k, L, where L is the original segment, or I guess you could start in the middle of the process with a path, but the original segment's length. Okay, so she starts with a line segment, then makes path 1. So Anne does this process. Anne does this bumping process k times. So 4/3 to the 5 n is an integer. We want the smallest value of n that does this. Now the 4 to the 5 doesn't really matter, but it's the 3 to the 5 that does. So 3 to the 5 divides 4 to the 5 n, but we can see pretty quickly that means 3 to the 5 must divide n, because 3 to the 5 and 4 to the 5 have nothing in common. This is entirely a power of 3. This is entirely a power of 2. So all the factors of 3 must be in n. So the smallest such n is 3 to the 5, or 243 itself. And there we go. Okay? And they didn't want us to say what the length is after path 5. No. So we're good. All right. There it is. So we explained sort of our general formula, and then we sort of applied it to our particular situation, and then we were able to get our conclusion, a proper conclusion about n. I'd say that's probably worth 3 marks, and D likely was 3 marks for that one. Okay, so that was question number 2. We are halfway done. 2 more questions to go. I'll see you for question number 3 next time. Thank you guys so much for watching, and have a wonderful day.